Lord have mercy. Ooh, it's 2026. Thought we'd have those robots helping me with these house chores by now. Ooh. How much did they even cost? $25,000. Oh my Lord. I ain't doing all that. I got grandkids. They're mechanical engineers. I'm sure they can help me build one. Or at least make me something to help me clean something.
So we're not actually making a house cleaning robot. At least not yet.
Well, that's kind of the point. Robots are everywhere right now. In warehouses, manufacturing lines, hospitals. But teaching them to do tasks autonomously, that's still very, very hard. I mean, for them to complete a task, you have to program line by line, talking a bunch of if-then statements. And that's really hard and doesn't generalize well anyways. So we asked, what if we can teach it to do a task autonomously?
So what Faber's talking about is called imitation learning. So basically how it works is we do demonstrations with the robot. The robot observes from the data we collect during the demonstrations, and then it learns how to do the task.
That's what we thought our product was gonna look like. Easy peasy. Collect data, train model, robot works, we graduate.
But things change. This is how it actually looked like. Had a bunch of dancing around, over here, come back. A lot happened.
We started with a framework that was made for 2 arms, 4 cameras, and we had half of that hardware available to us.
And we spent weeks trying to adapt code to hardware that was never gonna work.
Weeks. So we had limiting processing unit. We were running the entire data collection on Hunter's regular school laptop, the Lenovo Summit 7X Pro, limited GPU.
And not only that, but we were also losing frames due to bandwidth.
So a lot of problems. We eventually, after 4 months of working, we had to scrap the entire framework we built and pivot to a new pipeline.
And after we did that, we took 400 demonstrations. 400 demonstrations.
The thing about engineering is when you make mistakes, you don't give up. You adapt, you overcome.
We built a whole new pipeline in March, so we had 2 months to complete an entirely new thing, but we pivoted from data collection, from teleoperation to data collection to training on our own hardware, the Elephant Robotics C650 and M750.
And then we ended up training our ACT pipeline on 100,000 steps. My biggest takeaway was the gap between theory and hardware is massive.
Yeah, and for me, it really was just, there were days that I wanted to give up. I mean, we were here for very late nights, and at some point putting in 80-hour work weeks. But it's about showing up. There's no stopping until you got it, you're getting stopped, and that's on design day. So putting your hardest and work hard, and we got success, yeah.
We also want to take a moment to thank Professor Dr. Dong. He's been a great help for us on our project. He's always given his support in any way that we needed it.
Yeah, and a big thank you to the College of Engineering and Polymer Science for all of their support financially and otherwise in this project. This has been one of the hardest but most rewarding thing we've worked on in all of our 5 years at UA. Go Zips. I'm thirsty. Gotta keep working. Some water should be good right now. Oh, thank you. Oh. Thanks, robot. Sure got my back. That was good.